Question 3. The resistance inside a voltage source. Another name for a voltage source is simply a battery or an electromotive force. So the resistance inside a voltage source is called the internal resistance. It's called internal resistance is because it's inside the battery. Okay, question 3b. A textbook statement reads as follows. The potential difference across the terminals of a battery in a circuit is the same as its EMF, electromotive force, if the circuit resistance is high. Explain if this statement is true. Okay, well, what is potential difference? It's just another name for voltage, because potential difference, voltage is always measured between two places, so it's a potential difference across the terminals of a battery in a circuit is the same as the electromotive force. So they're saying, does epsilon equal V? Okay, that's the question. Now it says if the circuit resistance is high. Okay, so what does having a high circuit resistance mean? Well, if we look at current equals voltage divided by resistance. What that means that if R goes up or is high, if R goes up, that means I goes down because it's inversely proportional. Okay, so I goes down or is low. Now, why do we care about current? Because what we care about is that terminal voltage. Okay, so that terminal voltage equals the electromotive force minus the voltage lost through the resistor, IR. So if this I is really, really low, then this whole voltage here is nothing. There's no voltage lost inside that resistor, inside the battery, and so voltage does in fact equal epsilon, the supply voltage. So in fact, the answer to this question is true. 3c. A battery has an electromotive force of 9 volts and a resistance of 0.82 ohms. It is connected in a circuit as shown in the diagram below. So it has an internal resistance of 0.82 ohms and is connected to a variable resistor of 5 ohms. Okay, and the question is, calculate the voltage across it. So we want to know what is the voltage across here. So in order to be able to find out that voltage, we need to go voltage across the 5 ohm resistor is simply the current going through the 5 ohm resistor times 5, okay, or times the resistance. So we need to calculate what is the current. In order to know the current, we need to know the total resistance. So I total equals voltage total, or supply voltage divided by the resistance total. Okay, so the total voltage over here is 9 volts. Now what is the total resistance? We have a 0.82 ohm resistor in series of a 5 ohm resistor, and so we just simply add these resistances. So the total current is going to be 5.82 ohms. Okay, so the total current, come over to our calculator, is 9 divided by 5.82 is 1.54, or actually 55 amps. Okay, so we can come back over here. The voltage is going to be 1.55 times the 5 ohm resistor times 5 equals 7. Now how many significant figures? We've got 2 significant figures, 2 significant figures, 1 significant figure. So the answer should really be 8 volts, but we'll call it 7.7 volts, the 2 significant figures, but technically the answer is 8.